We're on lesson 5 of chapter 10, in which we'll interpret box and whisker plots. So first we'll make a box and whisker plot, then we'll interpret a box and whisker plot. So a box and whisker plot is a diagram that organizes data into 4 groups. And we're working with mostly medians here. So when you have a data set and it's listed from least to greatest, you start by making a box and whisker plot with your median. You have to find that median. So when you have a median, you have an upper half and you have a lower half. And I said we're working mostly with medians, and you'll see again that with the upper half you find the median of that, and that becomes your upper quartile. With the lower half you find the median of that, and that becomes your lower quartile. And as you can see, when we found the 2 quartiles and the median, we have now organized this data into 4 groups. Group 1, 2, 3, and 4. So as you construct a box and whisker plot then, the median is this line in the middle. The upper quartile and lower quartile form the edges of the box, and then the highest numbers and the lowest numbers form the whiskers. That's why it's called a box and whisker plot. So it all forms perfectly. So the 132 and 141 are located on the whisker. The 155 and 165, part 2, are located inside the box to the left of the median. 180 and 191 are both located on the box to the right of the median. And then 213 and 220 are located on the whisker to the right of the box. If you're looking at percentages, each section here represents 25% of the data. So this is 25%, 25%, 25%, and 25%. So as we're making estimates by looking at box and whisker plots, we can analyze it and figure out how much data is in a certain area. First, let's make a box and whisker plot. It says the lengths of songs in seconds on a CD are listed below. Make a box and whisker plot of the song lengths. So we have all this list of numbers here, and what we need to do is we need to list this from least to greatest. So I see a 173 here, and that's the least. Next I see a 179, followed by a 181, followed by 198, then it's 206, 239 is next, 246, 250, 251, then 257, 261, and 295. So the first thing we do is we look for that median. So if we count out from the outside, by crossing off the outside numbers, we find our median at 239. So this becomes our median. And as we construct our box and whisker plot, the median we saw was that center line in the box. So let's construct that center line at 239, right about here. So now we have our numbers above the median with which we can make an upper quartile. So I have 5 numbers in the upper region here, making this my upper quartile. And as we saw before, the upper quartile is the upper part of the box. So 257 is at the edge of the box. So we make our edge of the box right here. And we'll make our lower edge the lower quartile, which is 181. So going all the way down to 181, this is the left edge of our box. So now we can make our box in the box and whisker plot. Now we just need to come up with the whiskers. And the whiskers go all the way out to the lowest and highest numbers. So 173 is our lowest number, which would be right about here. And 295 is our highest number, right about here. So we go all the way out to those whiskers. And now we've made our box and whisker plot. The median's here, upper quartiles and lower quartiles here, and the whiskers going all the way out to the ranges. Now we can interpret a box and whisker plot. So it says the box and whisker plots below show the normal precipitation in inches each month in Dallas and in Houston, Texas. So here's Dallas and here's Houston. So it says for how many months is Houston's precipitation less than 3.5 inches? So by looking at this box and whisker plot, we should be able to figure that out. Here we see 3.5, and that's the left edge of the box. So we're looking for something that's left of that. Well, as you saw before, we saw that everything to the left of the box is this lower section here, this first section. And each section in a box and whisker plot represents 25% of the data. So that means this is the only section that's below 3.5, making that 25% of the time. So a year is 12 months, so we need to find 25% of 12. Well, 1/4 of 12 would be 3. So it would be 3 months that we would expect precipitation to be less than 3.5 inches. Now it's asking us which city's rainfall has the greater range. Well, we know the range of the data, this is the lowest amount and this is the highest amount for each one. So we should be able to find that range using this data here. We have 1.9 and 5.2. So 5.2 minus 1.9, that's going to equal 3.3. Houston, on the other hand, is 5.4 to 3.0. That's a range of 2.4. So that tells me that Dallas has a greater range from its most rainfall to its least. So we'll say Dallas. Now we're looking for the city's rainfall that has the greater interquartile range. So we see that we have the lower quartile and the upper quartile making the edges of the boxes, and it's looking for the range between the edges of the boxes. So we're looking at interquartile range. We have 3.2 to 2.3 for Dallas. That's 0.9 for Dallas. Houston, we're at 4.4 all the way down to 3.5. That looks like 0.9 for Houston. So therefore, they both have an interquartile range of 0.9. So we're going to say it's the same.